The last topic in this chapter is about the shape of molecules. So electron pairs are surround an atom. They repel each other, and this is referred to as valence shell electron pair repulsion or VSEPR theory. The VSEPR theory helped to predict the electron pair geometry and as well as the molecular shape. The electron pair geometry indicates the arrangement of bonding and non-bonding electron pairs around the central atom. The molecular shape, on the other hand, indicates the arrangement of atoms around the central atom as the result of the electron repulsions. So let's take a look at the example of a tetrahedral molecules. Methane is an example of tetrahedral molecule. It has 4 pair of bonding electrons around the central carbon. If you draw the Lewis dot structure of methane, carbon at the center have 4 bonding electron pair. If you place the electron pair at the 4 corners of a tetrahedral, they are repelled to each other, and therefore the geometry is tetrahedral, and the molecular shape is also tetrahedral. Based on the bonding electron pair, you can see that you can use the table to predict the electron pair geometry and the molecular shape. The next molecular shape is trigonal pyramidal. So in ammonia, the central nitrogen atom is surrounded by 3 bonding pair and 1 non-bonding pair. I show here the Lewis dot structure of ammonia. So nitrogen at the center, there are 3 bonding pair with 3 hydrogen and 1 non-bonding pair. And therefore the electron pair geometry is tetrahedral, and the molecular shape is trigonal pyramidal. So you see that here is the electron pair where the electron pair repel each other at the 4 corners of a tetrahedron. But the shape of ammonia, you can see that there nothing is unlike methane. You have another hydrogen up here that make the molecular shape tetrahedral. Ammonia only have 3 hydrogen, by only 3 atoms. It makes the shape a trigonal pyramidal. How about bent molecules? Water is an example of a bent molecules. So in the Lewis dot structure of water, it shows that 2 bonding pair bond with 2 hydrogen and 2 non-bonding pairs. And therefore, the electron pair geometry is tetrahedral, but the molecular shape is bent. You see that like ammonia and methane, where non-bonding electron pair is arranged in a tetrahedral, but the molecular shape of water is a band because only have 2 hydrogen, 2 oxygen only by the 2 atoms, and that's why its shape is a band. On those sometimes when an atom binds to atoms, it's not always the bend, like an example of carbon dioxide. Carbon dioxide is carbon at the central atom and bonded to oxygen, but it's not by 1 electron pair, by 2 electron pairs. And these 2 electron pairs are, will be at the opposite sides of the carbon. So it's over here and over here. And it pulled on the electron equally away from carbon by D2 oxygen. And therefore the electron pair geometry and the molecular shape of carbon dioxide, they both are linear. How about a trigonal planar molecules? So in example here that we is a formal aldehyde, CH2O. Now the central atom with carbon for most all organic molecules, when you write the Lewis dot structure of the organic molecules, the carbon should usually the central atom. So here is the Lewis dot structure of formaldehyde CH2O. They can see that carbon is bonded to by 1 oxygen and 2 hydrogens. So, but for oxygen, it's have a double bond, but for its hydrogen, it's a single bond. The electron pair geometry and the molecular shell, they are both trigonal planar. So all the atoms in the formaldehyde molecules are the same plane, and therefore it's called trigonal planar. Planar means it's on the same plane. Trigonal means that three, like 3 points, right? And this is the different than ammonia molecules, Na3, of which the nitrogen atom is a different plane than the hydrogen. So for ammonia, it's not a trigonal planar, it's trigonal pyramidal. So that will be end of the last topic of this chapter about the electron pair geometry and the molecular shell.